All right, guys. So we're going to pick up kind of where we left off yesterday. We're going to be using some right triangle trig today to solve word problems. Here's a few more before we really get to the word problems. Here's a few more identities. We wrote down a bunch of trig identities yesterday. We wrote down the reciprocal identities, the quotient identities, and the Pythagorean identities. All right. So these are called the co-function identities because they all go along with their cos, right? Sine and cosine, tangent and cotangent, secant and cosecant. So basically, any trigonometric function, like along with its co-function, all right, can, if you have the complement, right, it's going to be equal to it, right? So like sine of 53 is equal to cosine of 37, right? So whatever the complement is, it's going to be equal to its cofunction of the complement. It's not, these identities aren't used a lot, but in a few specific cases they can come in handy. If I recall correctly, one of the upcoming trig tests has a bonus question where these are required. Okay, so all right, this is just a little bit of review from something that you should have gone over in geometry. All right, but we'll definitely go ahead and talk about this a little more. So we want to talk about angle of elevation and angle of depression. Okay, so angle of elevation is very easy and very intuitive. All right, so let's say, for example, some fun little stick person is here. All right, and there's I don't know, some bird's nest up here that he's looking at on the corner of some building. All right, so if the person's looking up here, all right, from his eyesight, from the horizontal from his line of sight, all right, this angle right here is the angle of elevation. Right, it is important that it's the horizontal from like line of sight. It's not necessarily from the ground. Sometimes we assume it's from the ground if we don't have any better information to deal with. All right, but in general, like if you know the height of the person's eye level, right, you have to kind of factor that in. All right, now similarly, if there's a bird up here in the nest, all right, and it's looking back down at the person, all right, the bird's eye level is up here, all right, so this angle right here is actually the angle of depression. All right, now typically when we're using these things to solve problems, we're dealing with a triangle here. What do we notice about this angle of depression? How does it relate to this triangle? Is it even inside my triangle? This angle out here? No, it's not inside the triangle, okay? So we have to be very careful, all right? If you're given the angle of depression, a lot of students try to put it here, but it's not. How does this angle, the angle of depression, relate to this angle, though? Yeah, it's complementary, absolutely. All right. So these two are complementary. Or how does the angle of depression compare to the angle of elevation here? Anybody remember your geometry?
They're congruent
Yes, they are congruent. Why are they congruent? Do we remember?
because if you have two angles, if there's a rectangle and you have two angles on opposite sides of a line that bisects each corner of the rectangle, each angle on both sides of that line are going to be congruent.
I mean, I understand your reasoning there, but we're not necessarily saying that this is an angle bisector, right? So we can't say that it's bisecting. But you're thinking along the right lines. If you remember from geometry, all right, since this is a horizontal line and this is a horizontal line, these two lines must be what to each other? Parallel. All right, and we had a theorem in geometry that says if we have two parallel lines cut by a transversal, then alternate interior angles are congruent. Okay, so the angle of depression and the angle of elevation are congruent. All right, so if you're given the angle of depression, you can either put its complement here, all right, or you can just put that exact same angle here. All right, so we'll talk about that in some examples here. All right, so that's a pretty small picture there. Nope, I guess I can't really do a whole lot with it. Okay. So a surveyor is standing 50 feet from the base of a large tree, as shown in the figure. The surveyor measures the angle of elevation to the top of the tree as 71.5 degrees. How tall is the tree? Okay, so they give us this picture here, all right, and I'll kind of just redraw it as a triangle. All right, so he measures this angle as 71.5 degrees. He's standing 50 feet away from the tree, and we want to know what the height of this tree is. All right, now here it actually gives the angle of elevation as from the ground, so we don't have to worry about any modifications there. All right, so thinking of SOHCAHTOA, which we talked about yesterday, refreshed a little bit if we will. All right, this is my angle that I'm given. So this is kind of the angle of reference. So when we talk about opposite, adjacent, hypotenuse, that kind of stuff. We're basing it off of this angle. Okay, so what side is this as far as opposite, adjacent, or hypotenuse? Opposite. And what piece is this? Adjacent. Which one of my trig functions deals with opposite and adjacent? Which one has an O and an A? Yes, tangent. All right. So from here, we know that the tangent of some angle theta is equal to the opposite over the adjacent. All right. Well, using this information here, all right, my angle is 71.5 degrees. The opposite side is what we're looking for, the height, and my adjacent side is 50. All right, so if I want to solve this equation, what is the only thing that I have to do? Say that again. All I hear is mumbling.
Multiply by 50.
Yes, multiply by 50. Thank you. All right, so you multiply both sides by 50, all right, and that gets our h by itself. So now we can just go ahead and use our calculator. All right, what do we have to be careful about with our calculator? Anybody remember? What mode we're in, okay? We're dealing with degrees here. I'm already in degree mode, so I'm good to go. All right, so now all we have to do is hit tangent. Well, I guess we can do 50 first. 50 times the tangent of 71.5 degrees, and we get 149.434 feet. Bada bing, we're done. Pretty straightforward and easy, yes? Yes, no, maybe so? Great, amazing times. All right, we'll skip these so we don't have to get out our textbooks. Okay, so a 10-foot ladder leans against the side of a house. The ladder makes a 60-degree angle with the ground. How far up the side of the house does the ladder reach? All right, so we obviously have some ground. We have a house. Yay, house. All right, we have a ladder going up the side of the house. The ladder makes a 60-degree angle with the ground, and the ladder is 10 feet tall. So how far up the house, this is what we're looking for. All right, how far up the house does it go? So the picture is drawn, so it's relatively set up for you. So why don't you try to go ahead and use SOHCAHTOA and solve that problem. Okay, so this should go relatively quickly. All right, so We have our triangle here. Of course, we want to think about SOHCAHTOA. This is my angle of reference, all right? This side here is my opposite side. This is my hypotenuse, all right? So that would be sine of theta is equal to opposite over hypotenuse, all right? So in this case, plugging in our information, we have the sine of 60 degrees is equal to the opposite, which is h, over the hypotenuse, which is 10. So to solve for h, all I have to do is multiply both sides by 10. So h is equal to 10 times 60, the sine of 60. So we go to our calculator, we say 10 times the sine of 60 degrees. Bada bing. All right, so 8.660. The calculator by default is in radian mode. So if you haven't gone into mode and changed it, you would get a very different answer if you plugged that in. Okay. Got it? Cool beans. Okay. That's really it, guys. Like this is really straightforward. Okay. All we're doing is SOHCAHTOA, plug in the pieces that you're given, plug it into your calculator, call it a day. Okay. So what I want you to work on for the rest of the day, all right, if you go into Google Classroom and go to classwork, all right, Delta Math didn't have any stuff like this that worked for me. All right, so I just went ahead and assigned like an actual worksheet, right? So the PDF is here. This is just some more explanation of angle of elevation and angle of depression, which we went over. This is your SOHCAHTOA up here, all right? But all of the actual work, all of the actual questions are down here, okay? So just go ahead and work on these questions for the rest of the day, all right? You should be able to finish them relatively easily. Of course, you have any questions, just let me know. You'll turn this in since it's not on Delta Math. Just turn in your work just like you would like a test or quiz where you have the, the PDF in front of you. So just take a picture or scan or whatever and submit it through Google Classroom. Cool beans. Those of you that are here, would you like me to actually print this out for you so you have a hard copy? Okay, I can do that. Cool. Yep, I'll do that. All right, so those of you at home, you can go ahead and hop off and just work on these problems. And those of you here, I will print off a copy for you.